Yes, but computer is allowed anyway. Sorry, calculator is allowed. Yes, you use. Yes, on the GRE, right? Calculator is allowed. Calculator is allowed. Sir? Is what? Okay. Yes, calculator is allowed. But look at this. 2 divided by 0.5 is 4. So 2 of them are equal. Yeah. 2 divided by 0.5 is 4. That is why I said if you have used a calculator. But you don't also need, you don't need to use calculator to do it. Now, see what we are going to do. We are not going to do questions that seems a little hard. So until we get to the end. So let's leave number 2. Or do you think you can see in a certain sequence, each term after the first term is obtained by subtracting 1 from the preceding term and then dividing the difference by 3. The fourth term of the sequence is 4 over 3. Okay, so the fourth term of the is 4 over 3. In a certain sequence, each term after the first term is obtained by subtracting 1 from the preceding. Maybe it's something we can set up. Is that not? Let's try. So it said the fourth term of the sequence is 4 over 3. In a certain sequence, each term after the first term is obtained by subtracting 1 from the preceding term and then dividing the difference by 3. Okay? The fourth term of the sequence is 4 over 3. So we can work back, right? We can work back. We can work back the first term of the sequence. So we can work back. Let's do this. Let's go. The fourth term of the sequence is 4 over 3. What are we doing? In a certain sequence, each term after the first term is obtained by subtracting 1 from the preceding term and then dividing the difference by 3. That means we need to multiply first by 3, then subtract 1. 4 over 3 times 3 will now be 4. Okay, will now be 4. 4 minus 1. 4 minus 1 is 3. So the third term is 3. The third term is 3. So we need to go from this 3 now. The third term is 3. We need to do the same thing again. 3 times 3, 9. 9 minus 1. 9 minus 1 is 9 minus 1. No. Oh, we actually needed to. We subtracted 1, so we needed to add the 1 because it said by subtracting 1. So we needed to add 1. So that the other term should have been 5. Is that not? 4 over 3 times 3 is 4. Plus 1 is 5. So it should have been 5 rather. A lot of mistake. 5. 5 is the 5. So the other term is 5. Okay. The other term is 5. So let's move now. 5 times 3. 15 plus 1. Oh, yeah. 15 plus 1 is 16. Right? That is the second term. Okay? We are now already in the third term. So the third term, what are we going to do? We do the same. We multiply by 3. 16 times 3. See that 16 times 3 is already more than 48. Is that not? It's already more than 46. So A is greater. Let's move on. Number 2. Each of the 75 consumers in a survey reported the number of gallons of milk that the consumer purchased last week. The preceding table shows the frequency distribution of the number of gallons reported. The median number of gallons of milk reported by the 75 consumers surveyed. Let me show you this. It's something that you can also articulate on your own. Do you notice in 1, 2, 3, 4, 5? In 1, 2, 3, 4, 5. What is the median? Let's leave that one. That one will not help us. In 1, let's use scattered numbers. 6, 9, maybe 10. What is the median? What is the median? The median is 6. So do you notice that the median is how many numbers here? The median is n plus 1 over 2. That's 5 plus 1 over 2. That's 6 over 2, which is 3. So the median is the 6th number. Now let's apply that concept here. Yes. 75 plus 1 divided by 2. Is what? Okay. Is 38. So we are going for the 38 number. Where do we get 38? 10 plus 13. Okay. 10 plus 13 is 23. 23 plus 15. Yes, 23 plus 15 is what? Okay, so it is. Did you say 38? Okay, that means the median falls here. Is that not? Yeah, and if the median falls here, falls under here, what does it mean? It means that the median is 1.0.
Yeah.
So 1.5 is greater. All right, so we have solved 3 so far. Okay, we'll see how we have time. So let's go to question number 4. Question number 4. So here is question number 4. I want you to try. Remember, it said that s is greater than 0 and y is also greater than 0, but they are not necessarily like in terms. They are not necessarily integers. Okay. Sir? Okay, we don't have enough information, right? But where are you basing not having that enough information? But right, so we need, not having enough information is not the same. It's not. Remember that the same s is greater than 1. Y is also greater than 1. Sorry, 0. So we can start from these basics, the very basics. So we can start from these basics, right? S plus y. Let's assume that s plus y are 0.1 and 0.1. 0.1 plus 0.1. Quantity what? Oh, quantity A is greater than B. Okay, it might not be. It might not be if it increase. What if it increase? Have you considered what happen if it increase? If the numbers are very large. Let's make like let's think of 10 let's say 10 squared plus 10 squared. 200. So we are looking at the square root of 200, right? The square root of 200 versus 20. So quantity A is greater, right? Let's consider another thing. Let's try 0.1 and 0.1. Did you try smaller numbers? Like did you try 0.1 and 0.1? Did you try 0.1 and 0.1? 0.1 plus 0.1 is 0.2. So if you square them, so what will it be? No, say, but you know that the square root of numbers, they behave differently. The root of the root of numbers, the root of numbers less than 1, they behave differently. Remember that when you find the root of numbers less than 1, it actually increase, right? It's the square root actually will be higher than the original number, but we can select A and go. Or but if it's possible, we would have tried 0.1, something like 0.1 and 0.1 to be sure, because the numbers behave differently. The numbers behave differently when it comes to numbers between 1 and 0. Let's go to the next question. The product of all positive factors of 12 and 12 raised to the power 3. Let's quickly do that one. Remember what it's saying. The product of all positive factors of 12 and 12 raised to the power 3. All positive factors of 12 are 1 times 2 times 3 times 6 times 12. Is that not? Versus 12 raised to the power 3. If you check, this is already 112. Or times 4. I didn't put times 4. 4 times 1, 2 times 6 is 112. 4 times 3 is another 12. So they are equal. See. Let's go to the next one. The area of a circle region with radius r, and the area of where? The option is C. The option are the same all the time. See the option at the beginning of the option we are given at the beginning of the equation. Okay, number C. Okay, maybe it's when you join now. You just join, right? Number 6. Oh, really? Please, though, we are timed. So we have about, we started this at 1925. Let's go. Number 6. The area of a circular region with radius r, and the area of a circular region with radius r squared. R is greater than 0. You can choose anything. So let's choose 1 again. Let's choose 1. R is greater than 0. Remember, it's just saying pi r squared. You know that they can be equal. The area of circular region, they can be equal. They can be equal when what happened? They can be equal if r equals 1. What if r equals something else? If r equals something else, they will not be equal again. Or will they still be equal? Are we together? Okay, if it is r, if the area of a circular region with radius r and the area of circular region with radius r squared, if it is 1, which one is greater? If it is 1 with radius r, so if r is 1, r squared is also 1, is that not? I'm asking. We can try 1. If we try 1, which one is greater? If you try 1, they are equal, but if you try another number, they are not equal. So it means that it is varying. So we choose D. Number 7. There are 10 different books available to a librarian for purchase, each of the same. Remember that we are timed. Okay, so pi r squared and r squared, if you choose 1 and 1 squared are the same. But if you choose any other number, we are going to get a different answer. So the answer is D. I think it's very clear. Number 7. If you choose 1 is the same thing as 1 squared, so they are equal, and that's if you choose 1. But what if you choose 2? One will be 2, the other one will be 4. So we are getting two different answers, meaning D is correct. There are 10 different books available. There are 10 different books available to a librarian for a purchase, each of the same price, but the librarian has only enough money to purchase 9 of them. How many different collection of 9 books are there to be selected? So this is combination, because order doesn't matter, right? So this is selecting 9 books from 10, or what do you think? Order doesn't matter. So this is 10 combination 9. 10 combination 9 is 10 factorial over 10 minus 9 factorial over 9 factorial. Let's quickly work out this. This is 10 minus 9, so gone. And this is 10 times 9 factorial over 9 factorial. So 10. Okay, thank you. Number 8.
Sorry, go back, sorry, 1 second.
Okay.
It's fine.
Number 8. Number 8 is according to this diagram. I will always suggest, if you go to the exam, leave this diagram first. Number 12. The 5 point P, Q, R, S, and T lie on the number line in that order, where PQ equals QR, PR equals RS, and PS equals ST. If PT is, let's see, P, Q, R, S, T. PQ, QR, and RS, and RS, and RS. PQ equals QR. Okay, PQ equals PQ. PQ equals PQ. PQ equals what? Equals QR. Okay. PR. You see? PR equals RS. And PS equals ST. So, can we formulate this? Let's start from what is given. PT, all of them is, PT is 16. What we're supposed to do is just a matter of being as fast as possible. Okay, so let's start by putting S. Here is S. Here is also S. Now what is remaining is RS and ST. But we are told PQ equals QR, so we have put that one. PR, the whole of PR equals RS. So that means RS is 2S. That is just the meaning. RS is 2S. Right? RS is 2S. Then finally we are told that PS, the whole of PS equals ST. And the whole of PS is 4S. Right? Equals 80. So this equals ST. So this place is 4S. Now what are we looking for? We are looking for QS. We are looking for QS. Remember that QS here is 3S. What we need to do is, let's add all this. S plus S, S plus S plus 2S, 4S plus another 4S. That is 8S. We're going to say 8S equals 16. 8S equals 16. S is 2. S is 2. But what we are looking for is 3S. Because if you look at this, from Q to S is S plus 2S, which is 3S. What is 3S? If S is 2, what is 3S? You don't want to say anything. Oh. This thing S is, if S is 2, then 3S equals 6. Okay, let's quickly solve this. We have about 5 minutes to go. The operation is defined by A operation B equals A squared minus 4B squared for all numbers A and B. For which of the following value of S? For which of the following value of S is this equals to this? Okay. What are we now going to do? Is it not to say 2S squared? 2S squared, because 2S squared, that is 2 squared S squared minus 4. What is B now is 4 times 3 squared equals, I hope you are following, S minus 1 all squared, S minus 1 all squared, right? S minus 1 all squared minus 4 times 2 squared. Can we work out this fast? Is it possible we work out this fast? This is 4S squared minus 3 squared times 4. 3 squared times 4. 3 squared times 4. 9 times 4. 9 times 4. It's like you are tired. Don't go to the exam tired. Here, this one is what? S squared minus 2 S squared minus 2S. Okay. S squared minus 2S plus 1. Okay. Minus 16. What is the next thing? Bringing everything here. 3S squared. Let's bring 2S. Is it only 2S that we have? That's plus 2S. 1 minus 16 is 15. 1 minus 16 is 15. 36 minus 15. Wow. Let's go now. 1 minus 36 minus 16. It will have been good to leave this question. We have only 2 minutes. Let's see. We can actually come back to it. Okay. Okay, you are about leaving. Okay, that's no problem. Even the time is just remaining 2 minutes. Okay, that's fine. But the idea here is that we'll be able to get enough question out of 12 within the stipulated time. But okay, that's fine. Let's continue. People that are here, let's continue. Each postal code for a certain area is a sequence of 5 digits, where each digit is selected from the digits 0 to 9. How many such postal code have the property that the first digit is 9, the second digit is selected from the digit 0 through 6, and the third digit is 7? If the second digit is less than 6 and the third digit is 7, you see, the challenge with this type of question is how long it will take to make sense of it, right? Each postal code for a certain area is a sequence of 5 digits. So it's a sequence of 5 digits, where each digit is selected from the digits 0 through 9, all of them. How many such postal codes have the property that the first digit is 9? The first digit is 9. The second digit, how about the second digit? The second digit is selected from the digits 0 through 6. Is selected from the digits 0 through 6. Okay? And so we can start solving this question. No, this is counting. How many ways of doing? So we can put circles like this, 5 circles. The first one is we have only one possible way of doing only one, because the first one is what? The first one is 1. Let's go to the second digit. What is the second digit? The second digit is selected from the digits 0 through 6. Okay? The second digit is selected from the digits 0 through 6. How many can be there? Are we together? Okay, you now. Okay, fine. Each postal code is 5 digits. So the first thing we can do is mark out 5. 1, 2, 3, 4, 5. Where each digit is selected from the digits 0 through 9. How many such postal code have the property that the first digit is 9? The second digit is selected from the digits 0 through 6. And the third digit is 7. The third digit is 7. If the second digit is less than 6, so we have to put this second one. The digit that is 7, so there is one selection that must be 7. So let's bring it. So it's one way of doing it. And the second digit is less than 6. The second digit is less than 6. And the third digit is 7 or 8. If you have put 7 and you are saying 7 or 8, is what is also remaining? What is also remaining is again 1. If the second digit is 6, so you see all these ones, only one of them can be. Do you notice that the question did not state the restriction for the rest? There is no restriction for the rest, so they can be 10 and 10. They can be 10 and 10. So they can be, oh, it says all where somewhere. It says all where somewhere. Or 1 can be 7, 1 can be 9, but 1 carries all. Do you see? 1 carries all. The second digit is selected from the digits 0 through 6. Okay? From 0 through 6. And the third digit is 7. If the second digit, you don't necessarily need to put it the way it is said now. What matters is you have to treat all the restriction. One restriction is 9. Only 9 can be somewhere, and only 7 and the third digit is 7. Yeah, and as the digit can be 7 or 8. Only 9, only 7 or 8. These are the main restriction. Okay. 1 times 1 times 2 times 1 times 1 times 2 times 10. Okay. What else? What else is the 6? Is the 6. The second digit is selected from the digits 0 through 6. How do we handle that one? By the way, our time had elapsed. We will come back, so we come back to this. Let's see how many that we have been able to answer. By the way, you can also ask me a question for the ones that we have not solved. While we go back to the ones we skipped, I don't know how many we are able to answer. We solve from, I know we solve from 1, 2, 3, 4, 5, 6. Okay, 7. That's actually 7 questions. 7 questions out of 12 is already enough. Yeah, it's already enough if you get them correctly. 7 out of 12 questions is already enough to give you a pass mark. But not okay. We solve this, so we have 8 over 12. The ones we did not finish. So we have 14 and 15 that we did not finish. We did not even try 14 at all. Okay, so let's go back and start the ones that we skipped. We started skipping from, we did 7, so we started skipping for number 8. So the challenge with this number 8 now is this diagram. Let's see how we are going to cope with this. I'm reducing this. We still have time. Oh, the time is almost elapsed. It means we will continue this tomorrow. But my idea here is, if you press yourself, you'll be able to get enough questions. Of course, if you are solving it alone and you know what you are doing, you can get a lot more done. Yeah, of course, you can get a lot more done than when you are solving it with people, right? Because we are also trying to make a little sense, to add a little explanation here and there. Once you are given, if it's GRE, once you get to a session, try to answer all the questions you can before checking the ones that you need to think deeper before you arrive at the answer. Okay, so I can take your questions now.